Hi, everybody. This is the first lecture video for Chapter 2. I've decided to make um, a larger number of smaller videos. I tried making this earlier and it lasted over an hour, and I thought that was too long to watch all in one sitting, even with pauses. So what I'm going to do is I'm going to make a couple different videos that I upload into the Week 2 module, but all the notes will be collected here in this lecture notes, Chapter 2. All right. So Chapter 2 is about descriptive statistics. And remember, we've talked about descriptive statistics as being a way to understand the data that we have collected. And I want to start by talking about three different ways to describe that data, and they lie along a spectrum. So there's a spectrum from understanding numerical data, which goes from high detail to low detail. But the high detail uh, way to understand data has a low efficiency in understanding, and the low detail has a high efficiency in understanding. So it's a trade-off. Higher detail, lower efficiency, lower detail, higher efficiency. And that spectrum goes from raw data, which is high detail but low efficiency, to summary statistics, which are single numbers or a small set of numbers that describe the data. This tends to be low detail but high efficiency. And in the middle, we have visuals, which most statisticians prefer for understanding their data. It gives you more detail and doesn't lose too much efficiency for understanding the data set. So I'm going to use for this lecture, I'm going to use some data from one of your MyOpenMath assignments, homework assignments. Let me copy it in. And so here's an example of what raw data would look like for understanding numerical data. It's laid out in a table. There are 50 observations, and you can see what every single one of the observations are. Complete detail, you know, the first observation is 91, the second observation is 99, but low efficiency. It's hard to say at a glance what's the smallest one. What's the smallest observation? What's the largest observation? What's the center of the data, right? What's kind of the middle point? How spread out is the data? All of this is difficult to understand at a glance. It takes a lot more work to use the raw data to have that level of understanding, so it's lower efficiency. Nevertheless, starting with raw data is highly recommended for understanding your data set. Among the things that advantages that it gives you is you might notice with raw data if there's missing data, which you wouldn't necessarily notice with the summary statistic or even a visual. Or you might notice if there's some data that just doesn't make any sense, right? You look at this and all my numbers here are close to 100, except for this one, which is gigantic. And that might give you a clue that maybe there was a data entry error or something else was going on with the data. A step down the spectrum towards more efficiency are visuals. And I'm going to talk about three types of visuals. The first type is the stem and leaf plot. But I'm only going to say one thing about the stem and leaf plot, which is that I don't like these. I think they combine the low efficiency of understanding with low detail. In fact, I think it's harder to understand your data with a stem and leaf plot than it is with a raw table. And it doesn't give you any high efficiency for understanding the data. So that's all I'm going to say about stem and leaf plot in this class. My favorite visual for understanding understanding data is a histogram. And this is a classic visual for quantitative data. It quickly shows you how much your data is spread out, where your data is centered, where the most observations are, where they're living, if you have outliers, and a whole bunch of other important characteristics in a highly efficient manner. And it still preserves a fair amount of detail. So I'm going to walk you through how to create a histogram, and then I'll show you how to do it in RStudio, which is the fastest way to make these histograms. So a histogram is basically a bar graph where the height of each bar, or where each bar represents a range of values from the observations. And the height of each bar is the number of values in that range. And if you ever need to construct a histogram by hand, which you might need to do once or twice, follow these steps. First, find the minimum and maximum values, which you can do just by scanning. If you scan this raw data, I think the minimum value is 85 and the maximum value is 118. Then decide on how wide you want each of the bars to be. This is called the class width. I often refer to them as buckets instead of classes. So you can decide on how wide you want the bars to be, or you can decide on how many bars you want in your histogram. Once you decide one of these criteria, it determines the other one. So if you decide how wide you want the bars to be, it's going to tell you how many bars there will be, and vice versa. And then the third step is count the number of observations in each range. So suppose we want the width of bars to be 5, then we're going to count how many observations fall between 85 and up to but not including 90. So we have 1, 2, 3, 4, 5, 6 of them. And that's going to be the height of that bar. And then you make a bar graph with the height of each bar equal to the number of observations in each class. It's not completely unreasonable to do that by hand. If you have a small number of observations, 50 is considered pretty small. But often you're working with data that has 100 or 1,000 or 10,000 observations, and you would not want to do this by hand. So the faster way to do it is to use a computer to help you, in this case, to use R. And so I'm going to show you how to easily make a histogram in R. So here's our data. This is the exact same data that we had in the lecture notes. And I'm going to run that through. We can look at it if you want down here below. And there's our data. We're going to find the maximum and the minimum. What's the maximum? It is 118, and the minimum is 85, just like we saw when we scanned it. Now, step 2 is to decide on the width of the bars, but R actually makes that decision for you based on an internal algorithm. And so in general, you don't have to worry about that. There might be 1 or 2 times when you have to make a histogram with where the class width is a specific size. But in general, R will just do that for you. And here, I think R chose the class width to be 5. And in terms of counting, well, we can just use the built-in histogram. And there we go. There were 8 observations between 85 and up to but not including 90, 6 observations from 90 up to but not including 95, et cetera, et cetera. Now, from this data, I can quickly see that the center is in the realm of about 100, and I can see it's spread between about 85 and about 120, that the greatest number of observations fall between 95 and 100, that there are no big outliers. All of this data is pretty close together, and in fact, the distribution itself it's fairly flat. I mean, it goes up and comes down, but it doesn't have like a big spike in the middle. Doesn't have a big tail at the end. So you can pull out a whole bunch of information from a histogram just visually, and yet still have some decent detail. I know there are 8 observations between 85 and 90. That's a good amount of detail to have for your data. One thing in making a histogram is it's always nice to give the reader a little bit more information. So by adding this extra piece of code in R, the labels equal true, you get to put the labels right on top of the histogram. And the 10 here is cut off. There are ways to fix that, but I'm not going to worry about it. If you ever do want R to use buckets of a different width, you can do that. So here I want R to use buckets of width 10. There's a problem if I try to put the minimum to the maximum because R needs the bucket width to be 10 each time. So in order to make sure it's 10 each time, I go 85, 95, 105, 115, and up to 125. So I'm just going to put this code in here in case you want to ever change your bucket width. But as far as I'm concerned, you can just use whatever R gives you. So there we go. And I can even add the labels. There we go. 14, can't see that number. Maybe 18, 13, and 5. All right, so I'm going to put this code into the lecture notes. And whenever I put R code in, I'm going to change the font to look more like computer style font. So you can see that it's going to be R code. So you could copy this, drop it directly into your RStudio, and it'll run the same code and produce the same visuals for you. All right, I'm going to talk about one more type of visual for understanding data, and then I'm going to stop this video, and the next video we'll talk about summary statistics. So the third type of, oh, sorry, before I move on, there's some other things I want to say. So back to the histogram. So these are the key characteristics of data that I want you to be able to determine from a histogram. You should be able to estimate the minimum and the maximum values, estimate the spread. This is called the range, actually. Estimate the range of the data, estimate the center of the data, with either the mean or the median, and I'm going to talk about those in the next video. Get an idea of which class range of observations is most common, i.e. which of the bars is the highest. Identify possible outliers, and identify the general shape of the data. Let me show you really quick what would it look like if you had an outlier. So let's add a little bit of data and then make a new histogram. And we can see we have an outlier because there's a bucket over here that's not stuck up next to any of the other. There's a bar that's not aligned with any of the other bars. That's a good indicator that you have an outlier. Okay. All right, so last visual is the box plot. And sometimes that's called a box and whisker plot. And what a box plot does is it takes your data and it boils it down to 5 summary statistics and then puts those summary statistics in a visual for you. So this gives you a highly efficient understanding of the data with a little bit of detail. So it's more efficient generally than a histogram, but less detailed than a histogram. Now, what are those 5 summary statistics? The 5 summary statistics are the minimum, the maximum, the center of the data represented by the median, which is the middle value, and the first quartile, sometimes called the lower quartile, and the third quartile, called the upper quartile. And these two numbers represent halfway between the minimum and the maximum for the first quartile, and halfway between the median and the maximum. Sorry, let me start over. The first quartile is halfway between the minimum and the median, and the third quartile is halfway between the median and the maximum. 1, 2, 3, 4, and 5. And then describing the distance between the first and the third quartile is called the interquartile range. So let me show you what a box plot looks like. It's very simple to make a box plot. In R, you just say, I want a box plot of my data. And if you want the box plot to be horizontal, which is what I prefer, you can do horizontal equals true. And there is a box plot. So looking at this picture, you see a box and you see whiskers, which is why it's sometimes called a box and whisker plot. This left whisker here is the minimum. The right whisker is the maximum. The solid line in the middle of the box is the median. It's the center of the data. The left side of the box is the first quartile, and the right side of the box is the third quartile. But what that means is this dashed line, this whisker, has the 25% of the data that is smallest. The whisker on the right has a 25% of the data which is largest. The box contains the middle half of the data, which is split into the first quartile on the left and the third quartile on the right. Let me just, for fun, drop that image in here. And actually, I'll put the histogram in when I actually post the notes as well. And I'll put the code in there as well. Okay. So from a box plot, since it gives you a scale, you can pretty quickly tell that the smallest number is 85, about. The biggest number is something more than 115. The center of the data looks like it's around 102. The first quartile looks at it's about 95, and the third quartile is about 108 or so. So you get this data. You can see that the box, it looks pretty symmetric, right? These whiskers are about the same size. Each size of the box is about the same size. That can tell you that the data is roughly symmetric. There aren't any dots living way out there, which tells you there aren't any outliers. But instead of knowing, for example, in a histogram, how many observations there are between 85 and 90, all we can really say is that a quarter of the observations are between 85 and 95. So there's less detail. That's going to wrap up this video. The next video, I'm going to talk about summary statistics, and I'm going to start with the summary statistics that go into building a box plot. So thanks for watching this one, and